usually see a couple right now, usually turned in.
Okay, welcome back, and so I hope everybody had a good weekend, a good Easter weekend, if you did anything for that. Uh, so we're finishing up the second third of the class, I guess you can say. So the first third went to midterm one. We have one more chapter that goes to midterm two, and then we're essentially two-thirds of the way down through the course. And then everything after the second midterm is going to be on macroeconomics. So I think you might find that that's a little more well, at least a little more discussed about in the news. So we'll cover a bunch of macro stuff in a couple weeks. But we got uh, the chapter 9 homework due today. So it looks like, yeah, so a lot of students still need to post their chapter 9 homework. So try to get that in by today. Chapter 9 homework is due today. And then what I want to do today in class is chapter 16. And then we'll have a homework assignment for chapter 16, and then that'll be due next week. And then I think next week, since we got plenty of time, well, not plenty of time, but scheduled time, I think what we'll do next week is, because I have the midterm scheduled to be due in uh, 2 weeks from today, we'll just do a nice big review session for the second midterm. So we'll cover all the important things from chapter 6, 7, 8, 9, and 16. And make sure you come next week, because we're going to do some practice questions, do some practice problems, do a little review for the second midterm. Okay, so chapter 16 today. So this chapter jumps a little bit, and this is kind of this chapter, or the problem we're going to do, is kind of an extension of the production possibilities curve model that I believe we did in chapter 1. And so for chapter 16, we're only going to cover like one main area, because I want to get this specific type of problem down. So it's a bit long, and we'll go through some nice long examples. But there'll be one homework question. This specific problem is probably one of the longest, if not the longest, um, individual types of questions. But we'll go through plenty of examples. We'll do 2 full examples today in class. You'll have a homework question, you'll have a review question, and then you'll have one on your exam. So you'll have, you know, maybe 4 or so full questions to look from as examples, and hopefully that'll give us enough practice to get this idea down. But there's a bunch of steps, and we're trying to show how 2 countries or economies can have individual production possibilities curves, and no matter what, they can do some gains from trade, and we can illustrate that. It's actually a pretty fun concept. It's just a little detailed, but okay. So yeah, let's jump into that chapter 16. Okay, if you want to open up the study guide and the examples for chapter 16 here. Okay, and this one. All right, and then let me get we're not going to do much of the PowerPoint, because most of today's lecture or meeting is going to be going through these problems to make sure you understand them for the homework. But we'll do a few slides. Okay, so PowerPoint. And last one in the midterm 2 section, chapter 16. Okay. Okay, so here we go. So this is chapter 16 on international trade and exchange rates. Now, we're not going to cover a whole lot of the stuff because uh, I kind of think the topics from, well, so there's the textbook, it has, I think, 18 chapters. We cover most of the first 15, and I'm just going to cover a little bit of chapter 16 because it ties into the production possibilities curve. But we're not going to cover a whole lot of the exchange rates, kind of trade policies, trade deals, stuff like that. That's more of a that's jumping into more international economics and kind of beyond the scope of this class. But there's whole different classes and disciplines on international economics, exchange rates, stuff like that. If you're interested, I can point you in literature for this type of area or classes you can take. But for this class, which just kind of covers the basics, I just want to cover the gains from trade model that relates to the production possibilities curve because that's going to be more than enough on what to get from this chapter. Okay, so two key concepts, and they really apply to the same thing. We want to show through the production possibilities curve analysis, so you might remember that from chapter one, that we're going to have just two countries or two economies, and we're going to show that no matter what their production possibilities are for the two given countries respectively, they can most likely specialize in something and trade with the other country, and they're going to do that when they have a comparative advantage in one of the goods or the other, and I'll show what that means. And so they'll basically specialize in the good they have a comparative advantage in, which means they could essentially produce it cheaper or more efficiently. And then the other country will specialize in the good they have a comparative advantage in. And then what they'll do is specialize in a specific good, trade for whatever they want, and there'll be gains from trade for both countries. So let's just go through slides 7 to 12 and see if we can just highlight the idea of comparative advantage and gains from specialization in trade, and then we'll go through these um, two big examples to get the idea. So let's jump here to slide 7. All right, so we're going to assume there's going to be just two nations or two countries, two economies, same labor force, constant costs within the country, different costs between the countries, which is why they're going to want to specialize in trade. And in this example here, we'll have plenty of different examples, but we have the US and Mexico in this example. Okay, and if you recall, the opportunity cost ratio is the slope of the curve. So remember the opportunity cost from back in day one, I think it was. It's if you want to gain, if you want to produce something, you got to give up something else. So the opportunity cost of producing more soybeans in this example is how many avocados you give up, and the opportunity cost of avocados is how many soybeans you give up, right? So we're going to show essentially both countries specialize in one of the goods, and then they trade, and they're both better off. So we're going to find the country that has the lowest domestic opportunity cost in producing one good, and there's really always going to be one, and they're going to do that one, and then if they want to get the other good, which they don't specialize in, they'll have to trade with the other country, and they could do that at a more efficient level. Okay, so um, the opportunity cost of 1 ton of soybeans, I'll show in the chart, is 3 tons of avocados for the U.S. and 4 tons of avocados for Mexico. So just this is just an example, but the next slide shows the different production alternatives between the two countries. So remember, in chapter one, we just had one country, and we plotted the curve, and we did like the opportunity cost of producing more avocados or whatever the good was. Only difference here, which is kind of a big difference, is we have two countries, and they're both going to do their specific thing. specialize and then trade between countries to gain for both countries. So let's see. Okay. Um, this slide illustrates the comparative advantage. And so the comparative advantage, all right, this is a new concept, but the comparative advantage goes to the country which has the lowest um, domestic opportunity cost, which means that they give up the less. So they give up the least. I'm sorry. So look at soybeans. So soybeans, here, if you kind of look at the chart, it's not one to one, but so every time whereas Mexico produces um, 5 soybeans, they give up 20 avocados, right? Okay, and then every time the U.S. produces 10 soybeans, they give up 30 avocados. Okay, so if you convert that to just one to one, it's basically like we did in the example from chapter one. If you let's see, divide by 5 for this one, and divide by 10 for this one, you would get this. Essentially, Mexico must give up 4 tons of soybeans to get 1 ton. Mexico must give up 4 tons of avocados to get 1 ton of soybeans. So if they want to get 1 ton of soybeans, they give up 4 avocados. Now the U.S. to get 1 ton of soybeans, they only give up 3. So it's a little tricky at first, but you want to look for the country that gives up the least. All right, so just in literal terms. So the U.S. gives up 3, um, Mexico gives up 4. So Mexico is giving up more, right? And so that means that the U.S. can do it a little bit cheaper in this sense because they're only giving up 3 avocados compared to 4. So the comparative advantage here would go to the U.S. Now, it's probably going to mean that Mexico has the advantage in the other thing, which means over here, if you simplify it for avocados, Mexico gives up a fourth ton soybeans to get 1 avocado. You're just dividing this, you're converting this, right? If it over here it's 1 to 4, then if you divide it, it's 1/4 to 1. And over here, if it's 3 to 1, then if you switch it over, it's 1 to 1/3. Okay, so in terms of avocados, um, Mexico gives up a fourth ton soybeans to get 1, and the U.S. gives up a third ton soybeans to get 1. So look at for the country that gives up the least. Mexico only gives up a fourth compared to the U.S., which gives up a third. So these are fractions, but obviously Mexico gives up less, so they have a comparative advantage in avocados. So the idea here is that you look for the country, you find out the opportunity costs of both goods for both countries. You see which country has the lowest opportunity cost for each good. In this case, uh, the U.S. gives up less avocados to make soybeans, so they have a comparative advantage in soybeans. And Mexico gives up less soybeans to make avocados, so they have a comparative advantage in avocados. So what we do in this example is Mexico is only going to produce avocados, they're going to specialize in that, and the U.S. is only going to produce soybeans, okay, they're going to specialize in that, and then they can trade with each other, and the idea is that they'll be better off in the initial state. Okay, and so I'll show that we can specify different like terms of trade or deals in which both countries will be better off. So kind of there's a range. If we do there's a range of, if which the U.S. makes only soybeans and Mexico makes only avocados. There's a range in which they could both trade like 2 to 1 or 3 to 1 or 1/2 to 1, whatever. That they both can be better off. So as long as they trade within that range, that exchange ratio, that they're both going to gain. Oops, sorry, I skipped that. Okay, here, a trade that's going to work is 1 soybean, 1 units of soybean for 3 units of avocados, and for yeah, and so, oh, sorry, these are the boundaries. So initially, the opportunity cost for the U.S. was 1 soybean, they give up 3 avocados, and the opportunity cost for Mexico was 4 avocados equals 1 soybean. So as long as the trade is in between those two, they're both going to be better off. So domestically, the U.S. can do this, and domestically, Mexico can do this. Okay? So that means that we need to get somewhere for 1s is in between, like 3.5 or 3.7. So anywhere between these boundaries after specialization, the both countries are going to be better off with this trade agreement. Okay? So Mexico will pay less than 4A for 1s, and the U.S. will pay um, more than 3A. So it's got to be in between. Okay, so here we can settle on this, where 1 unit of soybeans is exchanged for 3.5 units of avocados. All right, see how that's in between the boundaries there? Okay, and if they make the trade like this one, essentially they're both going to be better off. So don't worry about getting all this at first. We're going to go through some big examples. I'm just trying to present the main idea. Okay, column 1, these are outputs before specialization, right? And so this means that Mexico choose 24 and 9, which is this one, point C, and the U.S. chose 33 and 19, okay, right there, point C. All right, so Mexico started here, and the U.S. started here, and then uh, the idea is that instead, to both be better off, that Mexico is going to produce all the avocados they can, which is 60, and the U.S. is going to produce all the soybeans they can, which is 30, and then they're going to trade. Okay, so if they started with this and this, then they specialize in these two, and then they trade at that rate. Let's see what happens. Okay, we start here for Mexico. We start here for the U.S. Mexico specializes, produces only avocados, which means 60 avocados, no soybeans. The U.S. produces 30 soybeans, no avocados. They specialize in soybeans, and then we're gonna trade at that ratio, which what not that, which was 1 unit of soybeans equals 3.5 units of avocados. Okay, so this deal here falls within there, right? So 1 to 3.5 is you can be multiplied by 10. That's 10 to 35. So if we follow that exchange rate, 1 to 30, 1 to 3.5, okay, a nicer math way is just multiply it by 10. So instead of 1 for 3.5 avocados, it's 10 for 35, right? So here, this is the specialization for Mexico. They trade away 35 avocados and get 10 soybeans at that exchange rate. And the US, they trade away 10 soybeans and get 35 avocados. So these go back and forth, okay? See how Mexico gets a minus 35 avocados, and the plus 35 avocados goes to the U.S. Mexico gets a plus 10 soybeans, and the minus 10 soybeans goes to the U.S. So they trade, right, minus 10 plus 10, plus 10 minus 35. So they're trading. Okay, and the result is for Mexico, 60 minus 35, they're left with 25 avocados. 0 plus 10, 10 soybeans. 0 plus 35, 35 avocados. 30 minus 10, 20 soybeans for the US. So these were the initial, column 1 were the initial production points. Column 4 are the options after trade, and you can see how they gain for all these goods. So after everything, Mexico has 25 avocados, so they gain 1 here, right? They have 10 soybeans, so they gain 1 soybean. The US has 35, so they gained 2, and 20 soybeans, so they gain 1. Okay, so all we're doing, which is kind of a long process, is start with something, specialize, trade, find out what we got after trade, and then show the gains, if there are any, for the two countries. So basically what we showed is Mexico got a +1 avocados, a +1 soybeans, and the US got +2 avocados and +1 soybeans, all by just specializing in the one they were more efficient at, and then trading with the other country to get a better allocation. Okay, so that's the general idea. And hopefully that makes some sense because we're going to go through a couple big examples, but that's the idea. So we're trying to do this type of analyses for different countries and show how you can find the good they should specialize in, and then how they can both countries be better off from specializing in trading. Okay, so I know these examples are going to take a while, so we're just going to go ahead and jump into them. So those are the main things. Those are the main concepts. Comparative advantage via the production possibilities analysis, and then how you can show gains from trade that I wanted to show you from the slides. There's a nice little video if you want to look at that on specialization and trade. Take a look there. But I think the best thing to do to get a grasp on these examples is just to jump into them. So I got two examples we're going to go through, and they all have multiple parts. I think A, B, C, D, E, F. Yeah, so A through F for two questions. And let me know if you have any questions for each part because you're going to do the same process for your homework assignment. So I did some of the work in Excel, and I have my Excel file posted on Blackboard, and you can use my Excel file as a template if you're going to do your graphs and your charts in Excel. Or alternatively, you can just do this on graphing paper if that's easier. So maybe whatever you've been doing before, do that. So if you want to do Excel, you can use my examples. If it's easier just to do this stuff with a ruler with graphing paper and take a picture and make a PDF, that's fine with me. You can do that too. So whatever is best with your resources or whatever's best to get the problem done for you, you can do that. Okay, so I'm just doing it in Excel because it's easier for me to illustrate it to you via WebEx. Okay, so let's start example number one. All right, and again, there's a bunch of parts, so if something doesn't make sense, please stop me because each part builds upon the other one. So number one, we've got an example here. The following hypothetical production possibilities tables are for New Zealand and Spain. Assume that before specialization in trade, the optimal product mix for New Zealand is alternative B, and for Spain is alternative S. So this is what you're going to get. You're going to get for these questions, you're going to get two countries or two economies with their own production alternatives for different goods, but the good alternatives are going to be different. They're both going to have the same two goods. So here we got New Zealand and Spain. They're both producing apples and plums, but you can see that the cost to produce those goods depends, and we need that information to do this. So these are the four uh, possible alternatives for apples and plums for New Zealand, A, B, C, and D. And these are the four possible alternatives for Spain, which are R, S, T, and U. And make a note, always look at where they start. So New Zealand's going to start at B here, and Spain is going to start at S. So basically, after the whole problem is done, we need to show that given where they started for New Zealand here and Spain here, that they're both better off in terms of at least a plus something for one or more of the goods. Okay, so you always pay attention to where you're starting from, because that's the benchmark by how you compare that you proved by specialization in trade. Yeah. Okay. So the first part, I believe, is just going to be to graph these, plot the points for each, and then graph them. Okay, so part A is draw the production possibilities curve for New Zealand and Spain, including the optimal product mix before specialization in trade. You don't really have to, well, I guess I usually highlight it or make a little note, but you just have to draw the curve. Okay, so I plotted the points here for New Zealand. So point A was 0 apples, 15 plums. Okay, point B, 20 apples, 10 plums. All right, so I just plot the points. There's point A from the chart, point B, point C, and point D. Okay, and then just draw a line. There's your production possibilities curve for New Zealand. Okay, and then for Spain, just plot these points on a graph where point R is 0 apples, 60 plums. Okay, point S is 20 apples, 40 plums. All right, and then just plot those 4 points. Okay, I put the letters on here. You don't have if you're doing this in Excel or you don't know how to do that. You don't have to put the letters. I just put them as a reference. But let me show you this. Okay, so here's for question 1. All right, this is on Blackboard. Okay, so all I did here, if you want to do this in Excel, you can use this. I just put them in like this. So here's points A, B, C, and D for New Zealand. Okay, and here's points R, S, T, and U for Spain. All right, and then all you got to do to plot them is just kind of select them and make a little graph. So just plot the points, just like we did with what were those examples from chapter 1, which were the budget lines, just like the budget lines. Okay, so there's the curve for New Zealand, and there's the curve for Spain. Okay, all right. Okay, part B are the comparative cost conditions such that New Zealand and Spain should specialize, and if so, what product should each produce? Okay, so they're going to be such, or else there wouldn't be a question. So it's going to say should they specialize? They're gonna, but you got to find out which good they should each produce. So what you want to do for part B is calculate or determine the opportunity cost of each good for each country. So here we go. Um, Plums. So the opportunity cost so this left side will be New Zealand. All right, so let's do plums first. Okay, so it's going to be constant because I simplified it to be everything's linear, right? So the rate is always the same. So look at New Zealand, and we're looking at plums first. So what does a plum cost them? Okay, look at the chart here, and you can see that every time they produce 5 plums, they give up 20 apples, right? Plus 5 minus 20. Plus 5 minus 20 no matter what. So each time they produce 5 apples, they give up 20 plums. Okay, that's 5 plums equals minus 20 apples. Now, to get that in terms of just 1 plum, just divide by 5, right? And that just means that 1 plum is equivalent to giving up negative 4 apples. Okay? Now, what about plums for Spain? Okay, you can see that they have a 1-to-1 ratio, but let's just do the whole process to make it thorough. Every time they produce 20 plums, they give up 20 apples. Plus 20 minus 20, okay? So, every time they produce 20 plums, they give up 20 apples. If you divide by 20, that means that 1 plum, they lose. Spain gives up 1 apple. Now, you want to first do the opportunity cost in terms of 1 good, right? So what's 1 plum cost for 1 country? What's 1 plum cost for the other country? We did that. Now, who gives up less? Okay, every time New Zealand produces a plum, they're losing 4 apples. Whereas when Spain produces a plum, they're only giving up 1. So by producing plums, Spain's not losing nearly as much. Okay, so they give up less. See how that they give up 4, they give up 1. So whoever gives up less has a comparative advantage. Now Spain gives up less, which means that Spain has a comparative advantage in producing plums, and they're in turn going to specialize in producing plums. So make sure you see that what I mean is the opportunity cost is who gives up more versus who gives up less. So once you get it in terms of one plum equals something and one plum equals something, whoever gives up less, in this case it's Spain, they're going to produce that good exclusively. Yeah. Now what about, so you know if you did it correctly that if if one country produces one thing, then it's probably likely that the other country is going to produce the other, but you have to double check to make sure. So let's do apples. New Zealand. So basically just you can either go back to the chart or you can flip this around. Um, well, let's just look at the chart. So for apples, for New Zealand, every time they produce 20 apples, they give up 5 plums, right? Plus 20 minus 5. 20 apples equals minus 5 plums. If you divide by 20, that means that one apple is equivalent to giving up 1/4 plum. So one apple equals minus 1/4 plum. All right? We know that Spain was 20 to 20 or 1 to 1. So if one plum equals one apple, then one apple is going to equal one plum, or one apple equals minus one plum. All right. So who gives up less in terms of one apple? Okay. So New Zealand gives up only 1/4 a plum, where Spain gives up a whole plum. So here, see that New Zealand gives up less. Therefore, they have a comparative advantage in producing apples. Okay, so New Zealand has a comparative advantage in producing apples, and they're going to specialize in producing apples. So what we got here from part B, which is very important, is that Spain's going to produce only plums, and New Zealand's going to produce only apples. Okay, so questions on how we determine um, which country should produce which, because this part's important because it kind of determines the rest. So first, the very first thing you have to do after you graph it is determine which country is going to produce what, and you got to make sure you see just put them get the opportunity cost for both goods for both countries, and see who gives up less, and then just assign the country that has the comparative advantage in producing that good to do only that. Okay. Everyone following this so far? Okay. Okay. Perfect. Um, Now, part C is going to tell you um, what is the total gain in both goods that would result from specialization only. So we're starting with just specialization. Okay. So what is the total gain in both apples and plums that would result from such specialization? Okay. So um, we started with we started with um, point B for Spain and point B for New Zealand and S for Spain. So just start with that. So New Zealand starts with 20 and 10, apples to plums, and Spain starts with 20 and 40. Okay, so here these points are given. So see that outputs before specialization. All right, so this is given. This is the point that was given for New Zealand. They start with on their original production possibilities curve 20 and 10, and Spain starts with the point that was given 20 and 40. Okay, and then all you got to do here for column 2. Hold on one second. Okay, sorry about that. All right. Okay, I had these like old I had these old headphones in the closet and they died like 6 months ago and they came to life and they wouldn't stop like pairing and I don't know what happened. It was like okay. Uh column two. So we got this is what we started with, column one, and then after specialization, right? Okay, Spain is going to produce only plums. If they produce only plums, that means they're going to produce all the plums they can, which is 60. Okay? The most plums they can produce is the max point over here, which is 60 point R. Okay? And then New Zealand is going to produce only apples, which means the most they can produce is 60. So specializing means that they go to the endpoint of their specialized good and produce all they can in that specialized good, which means that 6 point D for New Zealand and point R for Spain. Okay? So specialization means for New Zealand, 60 apples, no plums, right? And for Spain, 0 apples, 60 plums. Okay, so this is given for both countries. You determine what country is going to specialize in what, all right? And then that's here. Okay, and then just show the gain even before they make a trade. So see how we do this? Let me see. So the total gain in apples, all right, is with specialization we have 60 because this all the apples are being produced by New Zealand. Before we had between the two countries 20 plus 20, which is 40. Okay, 20 here and 20 here. So just by specializing, we gain 20 apples, or the economy did, or the two economies. Okay, for plums, right here, all the plums are now coming from Spain, which are 60. And before, if you add up the plums in the two countries, 10 plus 40 is 50, so we gain 10 plums. So just by specializing and adding up all the goods together, we gain 20 apples and 10 plums, right? Okay. Part D. Okay, so this part you have to determine where the trade, what the limits of the trade are, and then you can see what exchange rate benefits both countries. So the limits of the terms of trade, you can look at this in terms of one plum equals something or one plum equals something, or you could look at it in apples. It doesn't really matter as long as you specify it correctly. I think here I specified it in terms of one plum for both countries, but let me show you kind of how you get this. So um, take the take the country that specializes in something, and then take that initial uh, opportunity cost and make a note that they have to get better than that, otherwise they wouldn't trade. So let me show you what I mean. So Spain is going to specialize in plums, okay? Right? We determined that. So that means that in a trade, if they're going to make plums, okay, that means they want to get apples in a trade. Now, initially, they could have given up one apple for Spain. They could have given up one apple for 1 to 1. So right, yeah. So initially they're giving up 1 to 1 for Spain. So if they're going to specialize in plums and gain apples in the trade, then they got to get at least a little bit better than one apple. Otherwise, what's the point of specializing? They just stick with their domestic costs and get the one apple. So if they're going to specialize in plums, they got to beat their domestic opportunity costs because initially, right, one plum giving up one plum gives them one apple. Okay, so they can do that initially. So if they're going to specialize, they better get at least, but they better get more than one apple. All right. So basically, Spain needs to get more than one plum equals minus one apples in a trade. If they did not do that, then it wouldn't make any sense for them to specialize in trade because they can just get one-to-one initially. Okay, so in terms of one plum, okay, sorry. So that's for Spain. Now, for New Zealand, they're going to specialize in apples. Right? We determined that. And initially, what are they're so they're going to trade apples for plums. The initial trade-off for New Zealand for apples was one apple equals a fourth of plum. Okay, so that means that if they're going to make a trade, they got to gain back at least a fourth of plum. Otherwise, they wouldn't make the trade. So so it's a little confusing, I think, but I'm just trying to show you that uh, to, to to determine a trade that's going to benefit both countries, you have to find out what they're initially giving up, and you got to find a trade that benefits both of them by giving them more than their initial domestic opportunity costs, because otherwise it wouldn't do them any good to do that. Okay, so Spain, New Zealand needs at least a fourth of plum for an apple, and that's stated here. New Zealand needs to get more than one apple equals one fourth of plum. Okay, so the first two statements, all you have to do is start with Spain, know that they're specializing in plums, and state the original opportunity cost for plums. Okay, and then we know New Zealand specializing in apples. State that and state the original opportunity cost for apples. Okay, so this is what Spain needs to beat. This is what New Zealand needs to beat, and let's just put them in terms of either one apple or one plum, and then we can determine the trade. So it looks like I put them in terms of a plum. Um, this is already in terms of one plum equals one apples. Now to put this in terms of one plum, just multiply by 4, which means that 4 plums equals one, which means that one plum equals minus 4 apples, right? So this is already in terms of plums. This in terms of plums is one plum equals minus 4 apples, right? So restating these two conditions right here uh, determines what both countries have to get, and that means that the trade that they agree upon has to be in between these two boundaries. So the long story here is that the trade has to be somewhere in between here, which means that it's got to be they got to trade one plum for something bigger than one and less than 3. That's going to benefit both countries. Okay, if it's less than one of the countries isn't going to be better off. And if it's more than 4, the other country is not going to be better off. So we can do one plum equals 2 apples, one plum equals 3 apples, one plum equals 1.5 apples. Anything that's less than 4 apples and bigger than 1 apple is going to work for both countries. Okay, so part D is a little confusing, but that's the idea. Is you want to start with the country and the good they're specializing in, so Spain and plums, and state the initial domestic opportunity cost. And then if Spain's doing plums, New Zealand's doing apples, and state their domestic opportunity cost. All right, and then put them in the same in terms of the same one plum equals something and one plum equals something, and then that determines the limits of where you got to make this trade. You could also do it in terms of apples. So another way to write this condition, let me see if I can just type it in here, is let me do it like this. Okay, or -1. There we go. Okay, so do you see how both of these conditions kind of say the same thing? So this one is in terms of plums, and this one is in terms of apples. Okay, so we take these two conditions that we stated, and we want to put them, these are the same thing. So either put them in terms of one plum equals, or put them in terms of one apple equals. So this is one plum equals one apple, and this is one apple equals 1/4 a plum. So this is always 1 to 1, right? So that's the same. This one for apples goes right there, one apple equals -1/4 a plum, or if you convert this in terms of plums, multiply by 4, and one plum equals -4 apples. So these conditions say the same thing. Either the trade has to be in terms of plums, where it's one plum equals something um, bigger than one apple but less than four, or it's in terms of apples, and the trade is something bigger than 1/4 but less than one. Right? Each of those things say the exact same thing. Each of these things determine where the trade can benefit both countries. And the only difference is you're specifying in terms of plums or apples. Okay. So for example, like if you look ahead to part C, the terms of trade are one plum for two apples, and see how that comes in between these two boundaries, right? And that's the same as saying one apple for half a plum, which would also go in between here, right? So we're trying to find the trade. I mean, the trade I give you is gonna be in the right range, or else they wouldn't make the trade. But it's important to see what possible trade could occur because there's different exchange rates that the countries can do. Okay. All right. Part E. So now, let's suppose that the actual terms of trade are one plum for two apples. Okay, so see how that's in between the correct limits, and the actual trade is 12 plums are exchanged for 24 apples. So this is the rate, all right. But if we're doing 1 to 2, that's the same as 12 to 24. So if you're doing 1 to 2, all right, every plum is exchanged for 2 apples, then exchanging 12 plums will exchange for 24. So this is every plum gives you 2 apples, and the actual trade is 12 for 24. Now, part E in the chart is what are the gains from specialization and trade for both New Zealand and Spain. So this is the main point of the question here. So we already did columns 1 and 2. So just put these from part C. So we got column 1 here and column 2 here. All right, so those are done. Now let's do the trade. So the trade is given, right? So this is what they start with. This is specialization, and now we're going to trade exactly what the question says, which is whoever has the plums is going to give up 12 plums, and whoever has the apples is going to give up 24 apples. Okay? So New Zealand has the apples now. They're going to trade those minus those 24 apples and gain 12 plums. Uh, Spain has the plums now. They're going to trade those 12 plums and gain 24 apples. So see how the trade goes, right? This 24 apples go here, and these plums go here. That's it. Now, what are the outputs for both goods for both countries now after specialization and trade? So start with specialization. New Zealand has 64 apples. They traded away 24. They're left with 36. All right. After specialization, they had no plums, but they gained 12 in a trade. So 0 plus 12 is 12 plums. Spain specializes here. No apples, but they gained 24 in a trade, so they have 24 apples. And plums, they specialize, so they have 60, but they trade away 12 and they are left with 48. So these are the allocations after they trade. And the point here in number 5, which is essentially column 4 minus column 1, what they started with, is what's the gain. So now we have 36 apples for New Zealand. They started with 20, so that's a plus 16. We have 12 plums now for New Zealand. They started with 10, so that's a plus 2 plums. Now we have 24 apples for Spain. They started with 20, so that's a plus 4. And now we have 48 plums. Initially they had 40, and that's a plus 8. So basically, uh, all the countries got additions in all the goods. So New Zealand got a plus 16 apples, a plus 2 plums, and Spain got a plus 4 apples and a plus 8 plums. All right. Okay. Do we see how I got these? The key here is trying to get column 5, which is to show what they all gain in specialization and trait. Okay, so see that? And then the last part is just show the full new graph they could gain from doing the specialization and trait. So on the same graph from part A, or new graph like I did here, add the new production possibilities curve for New Zealand and Spain with specialization and trait, including the new optimal product mix from part E. So all you have to do here is show the new um, production possibilities curve with specialization and trait. All right. So so I did it here in the Excel file, which you can use as an example. Okay, so here's the one for New Zealand, and here's the one for Spain, and this shows that they're better off at all trades. And so I think if you're doing it in Excel, you can look at these examples, but the easiest way just to see it is start with the good they specialize in and show the other endpoint is if they trade everything, and then just draw a straight line. So let me show you what I mean. So okay, New Zealand Spain is going to specialize in plums. All right. So that means that they are going to start with the most plum with all producing plums. So here's Spain. Then we're going to start with 60 plums and 0 apples, right? So just start with the specialization point, 60 and 0. Where is that? Right there. Okay, so we're starting here. All right, just put that there and start there. So then for the other countries, show their specialization point and start there. All right. So for New Zealand, they're going to specialize in apples, and that means they're going to produce all the apples they can, which is 60. All right. So we'll start here. So basically, to do the last part, to do the graph, just start with the specialization point for both, which is point D, 60 apples, 0 plums for New Zealand, and point R, 0 apples, 60 plums for Spain. Okay. All right. So for New Zealand, here we go. We start with all right, they're specializing in producing apples, which means they're producing 60 apples. Now, the point of this new line is to show that any trade they make is going to give them a better allocation of plums than they had before. Okay, so see how the other line hit the plums mark. It went from 60 to 15. Okay, this new line is going to kind of go like that, and any trade they make at the 2-to-1 ratio is going to give them something better than they could have initially got. So start with the specialization point, and then show the curve. Essentially, by just if you draw a new intercept by trading all the goods they specialize in, then that'll show you where the line hits. So if we're trading apples and plums, at 1 plum for 2 apples. Okay, that means that we got 60 here for the specializing for New Zealand, and we got 60 here, and that means they can trade any of these 2 plums for apples. So if they trade all the apples at 2 to 1, they can get 30 plums, right? So each of these 2 gives them 1 apple. If they trade all of them, let's just say they could possibly get up to 30 plums. All right, if you get that endpoint and just draw the line, this is the new curve with specialization and trade. All right, so initially it was 60 here and 15 here. Now it's 60 here, and they can get up to 30 plums just by trading. Okay, so all you got to do is, again, start with the point of specialization. And I think the best thing to do is take the trade, which is 1 plum for 2 apples, show what they can get if they traded all that good they specialized in at the maximum point, and then just draw a point there and connect the dots. Okay? So they can gain anything in between um, by trading some apples for some plums, or if they wanted to, at the most extreme, they can trade all the apples and get up to 30 plums. These are all the possibilities they can do given this specialization and this exchange rate. And do the same thing for Spain. Um, they're going to specialize in plums, right? Which means the most plums they can produce is 60, which means they produce 0 apples, but they can trade any plum, okay, at the rate of 1 plum for 2 apples, right? So they can trade 1 plum for 2 apples, they could trade 2 plums for 4 apples, or they could trade all the plums and get up to 120, and that's why you put the point here. So anything along this new curve is a possibility they can get with trade. And yes, remember the original point for here was 60 goes to 60. Now they can get up to a possibility of 120 plums if they make that kind of trade. So that's the idea here for the new curves. Okay. All right, so you can see them here if you want to do that in Excel, or if it's it's easier if just do it in graphing paper. You might want to do that. Okay, we have a whole nother example, but questions on any of the parts and how to do this type of problem, especially parts D, getting the limits, part E, determining how much you gain of each good, and then part F, um, drawing the new curve. So sometimes the new curve is a little confusing, but I think once you see that if you start with the specialization point and plot the other point of where the maximum they can get if they trade all their goods is, and just draw a straight line, then that's it. And then anything in between is a possibility, but once you get the other endpoint, it's easy just to draw a straight line. Okay, questions on this problem? We're going to do a whole nother one, but everyone somewhat understand what we did? Yeah, all right. Okay, let's do the same problem again, and you can use these for your examples on the home. So we're gonna go through this one again, and then you're gonna have a homework question, which is essentially the same process, but you're gonna have different countries and different products, but you got to follow the same recipe. Okay. All right. Okay, number 2. Now, all right, the same setup. The following hypothetical production possibilities tables are for China and the U.S. Same that before. Specialization in trade. The optimal product mix for China is alternative B, and for the US is alternative U. Okay, so remember to make a note of the initial allocations was for China is B. This point, 24 and 6, and for the US is U, 4 and 12. All right, and then we're going to show how they're both better off by making a trade by specialization and trade given the comparative advantage. So part A is easy. All right, just draw the production possibilities curves for China and the US. Okay. All right, so all you're doing is it's plot the points, or even easier than that. But the best thing to do, I think, is just put the two extremes. So put point A and point F for China, all right, and then draw a straight line through that, and then put point R and point W for the U.S. and just draw a straight line through that. Okay, you can put the individual letters if you want, but the main thing is you get this endpoint, and the curve for apparel and chemicals for the U.S., and you get this endpoint and this endpoint for apparel and chemicals for China, and show where they start out. Okay, all right, we got that. Now we're going to determine what who has the comparative advantage in what, and who should specialize in what. Okay, so let's determine the opportunity cost for each good for each country. So we'll start with apparel, and we'll start with China. So what is China's opportunity cost for apparel in terms of chemicals? All right, so this one's easy because it's always 1 to 1. So they have them listed here in increments of 6, but you can see +6 chemicals they give up 6 apparel, or +6 apparel they give up -6 chemicals. So 30 and 0 over here, 30 and 0 over here, the increments of 6, and it's a 1 to 1 trade-off, right? So 6 apparel equals 6 chemicals, which means that 1 apparel is equivalent to giving up 1 chemical. Okay, but what about the US? The US, which one are we doing? Apparel. The US, each time they get 2 apparel, they give up 4 chemicals, right? So +2 minus 4, that's always the same, +2 minus 4. So any 2 chemicals, you give up 4, any 2 apparel, you give up 4 chemicals. Okay, so 2 apparel minus 4 chemicals. Divide that by 2. 1 apparel equals -2 chemicals. Now, who gives up less? Obviously, if China only gives up 1, where the US gives up 2 chemicals, then China gives up less. They have a comparative advantage in producing chemicals, and they're going to do that. So they're going to produce, apparel. They're going to produce only apparel and specialize in apparel. Okay, what about, well, we know what's going to happen, but let's finish the process for chemicals. Okay, so even if you figured out already who's going to specialize in what, you still want to determine the opportunity cost, because you need that for the limits of the trade in part D. Okay. All right. So we determined that it's 1 to 1 for the goods for China. All right. Now, what about the U.S. for chemicals? Every time they produce 4 chemicals, they give up 2 apparel. So +4 minus 2, +4 minus 2, which means that 4 chemicals equals -2 apparel. If you divide by 4, you'd get 1 chemical is equivalent to giving up half an apparel. So 1 chemical equals -1 half apparel for the U.S. Now, who gives up less? Um, China gives up 1 apparel. The U.S. only gives up a half, right? The U.S. gives up less, so they're going to specialize in apparel. they're gonna okay, this is they're gonna specialize in chemicals and produce only chemicals. So China's gonna produce and specialize in apparel only, and the US is gonna produce and specialize in chemicals only. Okay. C. What is the total gain in both apparel and chemicals that would result from such specialization? All right, so start with the initial point, which is going to be given. So always go back for column one, outputs before specialization. Just go up and make sure you see what the problem told you was that. Optimal product mix for China is B, 24 chemicals, 6 apparel, and for the US is U, 4 apparels, 12 chemical. Okay, so this part's given in the initial part of the question, so just type it or just put it in there. China starts with 6 chemicals and 24 apparel, and the US starts with 12 chemicals and 4 apparel. Just the point that was given on the initial production possibilities curve. Now, column 2, outputs after specialization, just one country is going to specialize in one thing and produce none of the other, and one country is going to specialize in the other thing and produce none of the other. So China is going to produce only apparel, and the most apparel they can produce is 30, which means 30 apparel, right? That's specializing, no chemicals. Okay, that's that right there. Now, if the US specializes in chemicals, the most they can do there is 20, right? 20 chemicals, no apparel. That's their specialization. Okay, now just by doing that, what did we gain in each of the things? So after specialization, we have 30 apparel, okay, and we have 20 chemicals. So what did we gain? So for chemicals, we got 20. Initially, we had 6 plus 12, which was 18, so we gained 2. Okay, for apparel, we have 30 now. Initially, we had 24 plus 4, which is 28. All right, so we gained 2. So just by specializing, nothing else, we gained 2 chemicals and 2 apparel, right? Okay. Part D. What are the limits of the terms of trade? So, again, this one's a little confusing, but what you need to do is just start with one country and start with the good they're going to specialize in and put the initial exchange rate. So China, we determined, is going to produce apparel. All right, so we need the initial apparel opportunity cost for China, which is um, 1 apparel equals minus 1 chemicals. Okay, so put that there. And the US is going to specialize in chemicals. Okay, so put the initial opportunity cost for chemicals for the US, which is 1 chemical equals 1/4 apparel. Okay, so we know that in terms of the specializing in the initial domestic opportunity cost, that China needs to get more than 1 apparel equals minus 1 chemicals in a trade, and the US needs to get more than 1 chemical equals minus 1/2 apparel in a trade. All right. Now, all you got to do is put these in terms of one good. I did them in terms of apparel. So 1 apparel equals 1 chemical, or put this in terms of apparel, which means that multiply by 2, and 1 apparel equals minus 2 chemicals. So any trade within these limits, 1 apparel equals minus 1 chemicals, or 1 apparel equals minus 2 chemicals, 1 to 2, or 1 to 1 or 1 to 2, or 1 to 1.5, or anything any trade of one chemical equals bigger than one chemical, or one apparel equals less than two chemicals is going to work. So 1 to 1.5 or something in between. But anything less than uh, getting one chemical for one apparel, or anything more than getting two chemicals for one apparel, is not going to work for at least one of the countries. All right, and yeah, you can also, let me just do it one more time in terms of the other good, just so you can, that it doesn't matter which uh, good you put it in terms of, it's the same thing. But if I were to write this same condition in terms of one chemical equals, it would be that this. Okay, or one chemical equals one apparel. Right? Okay, so you can either, this condition here is the same as this one. Okay, either of these limit scenarios would work. The exchange could be, to benefit both countries, one apparel equals something in between one chemical and two chemicals, or the exchange rate could be one chemical equals something in between one half apparel and one apparel. So the limits mean that those are the limits. So it, one apparel equals 1.5 chemicals would work, or one chemical equals 1/3 apparel would also work. Something in between those, right? Okay. So let's part E. All right, I'm going to give you a trade that's within the limits that you determined. So part E is, suppose the actual terms of trade are 1 unit of apparel for 1.5 units of chemicals. All right, so see initially how just that one apparel to 1.5 comes in between these limits exactly. So that works because it's in between 1 and 2, right? So that's a good trade for both countries. Okay, and then exactly 4 units of apparel exchange for 6 units of chemicals. All right, so these are the conditions. One apparel for 1.5 chemicals. This is the actual trade in terms of quantity. 4 units of apparel is exchanged for 6 units of chemicals. All right, so that's what you need in column 3 down here. Okay, what are the gains from specialization in trade for each nation? Um, Here's the big chart. So always have column 1. So you got the two countries, whatever they are, and column 1, which is outputs before specialization. There, that's given. Column 2, which is outputs after specialization. You got that in part C. And then these columns 3, 4, and 5. Column 3 is amounts traded. We're about to do that. Column 4 is outputs after trade. And column 5 is gains from specialization and trade. All right. So we got this already. We got this already. Let's start with column 3, which is what we trade. So it tells you what we trade. Whoever has the apparel gives up 4 apparel for 6 chemicals. Okay? So here's the outputs after specialization. So China has 30 apparel and 0 chemicals. So they need to get chemicals. So they're going to exchange 4 apparels for 6 chemicals, right? So minus 4 apparel. plus 6 chemicals. Okay, after specialization, the U.S. has no chemicals, so they need to gain apparel and give up chemicals. So they're going to get 4 apparel and give up 6 chemicals. Okay, so see in part 3 that we're just showing the trade. All right, the U.S. loses 6 chemicals and sends 6 chemicals to China, and China loses 4 apparel and sends those 4 apparel to the U.S. So there's the trade in terms of accounting. And column 4, what are the outputs after they specialize in trade? So just column 2 plus column 3, right? 0 plus 6 is 6 chemicals. 30 minus 4 is 24 apparel for China. 20 chemicals minus 6 is 14 chemicals. 0 plus 4 is 4 apparel for the US. So these are the outputs after specialization and trade for both countries. And what do they gain, if any, in terms of the initial starting point? So how much better off are they in terms of column 4 versus column 1? All right, let's see. So China started with 6 chemicals. Now they have 6. So they didn't do anything better there in chemicals. So no gain in chemicals. But they started with 24 apparel, and now they have 26. So they got a plus 2 in apparel. The U.S. started with 12 chemicals. They got 14 now, so they got a plus 2 in chemicals. They started with 4 apparel. After the trade, they have 4 apparel, so there's nothing there. So it's not always that both countries are going to gain both things, but the point of column 5 is no country is going to be worse off if you do this correctly. So, it could be better, but China got a plus 2 in apparel, and the U.S. got a plus 2 in chemicals just by specializing in trade. Okay. All right. The last part F, is let's see if we can show the new graph that shows all the possibilities given the specializing and giving the specific trade deal. Okay, so on the same graph, part F, or new graph like I did, add the new production possibilities curve for China and the US with specialization and trade, including the new optimal product mix from part E. All right, you don't need to put that, but you can if you want. All right, so again, start with the specialization point, trade all the specialized good for everything they can get at the given exchange rate, draw the other point there, and then draw a line, and that shows you all the possibilities with specialization trade. So let's start with China. Okay, China is going to specialize in apparel. And what does that mean in terms of the graph? That means they're going to start with point A, right? They're going to produce 30 apparel, no chemicals. So this is point A is where China is starting with after specialization. All right, so let's start with that, 30 apparel and 0 chemicals. Right there. Now, they can trade any of these apparel for 1.5 chemicals, right? Here's the rate. So anytime they trade away an apparel, they gain back 1.5 chemicals. All right, so what if they traded all of it? So basically multiply 30 times 1.5, and that's a possibility. If they traded every single apparel, they can gain up to 45 chemicals, which means that anything on this curve is a possibility after they specialize here and trade any of these amounts, right? So initially they had a 30 here for the intercept, and they had a 30 here. So remember, they could anywhere along the 1-to-1 they could do initially. Now with the trade, okay, they can produce 30 apparel or much more than 30 chemicals. So if they produce if they specialize in apparel and trade any of those apparel for any number of chemicals at the exchange rate 1 to 1.5, right, the new point that they trade to is better off, right? So the initial one was here, like 30 to 30, somewhere there, and the new one goes out. So any of these possibilities gives them more chemicals than the initial point, right? Yeah. Okay, what about for the US? They're going to specialize in chemicals, which means specializing in chemicals means they produce all the chemicals they can and none of the other things. So that means point W, 20 chemicals, no apparel. Where are we? Right there. Okay, we're starting here. Point W, or W prime, I called it here, is specialization for the US. Now they can trade any of those chemicals back for apparel at this exchange rate. So it's essentially, the math is a little bit difficult the other way, but uh, any of those chemicals can be exchanged at essentially zero point 0.6 apparel. If it's 1 to 1.5, then 1 divided by 1.5 is something like, I have it exactly here, but yeah, 2/3. So it didn't work out too nicely with the math, but uh, basically for the US, any of these 20 chemicals they specialize in can be traded for up to 13 and a third apparel. So sorry the math didn't work out perfectly, but uh, this one's 1 to 1.5, and the other way would be, you know, 1 to 2/3, because you got to flip it around. So if you trade all the 20 chemicals for apparel, you can get up to 2/3, which is 13 and a third. Okay, 2/3 of 20 is 13 and a third. Okay, so see that? So see this, the trade is specified in 1 to 1.5. So this can be traded, sorry, this can be traded at 30 to 45, and this can be traded the other way at 20 to 13.33. Right. Okay, so here's the specialization. They can get up to, each of these can be exchanged for 2/3 of an apparel, which means that 20 chemicals times 2/3 is 13.33 or something right there. Yeah, 13.33. And then anything else they trade for at 2/3 of a chemical to apparel, they're going to be better off. So initially it was 20, and the other intercept was 10, right? Now it's 20, and this is now 13.33. So any of these points on the new curve, they're getting more apparel just by specializing in trading. Okay, so that's the whole idea for the new graph, is to show that how the new curve uh, allows them to possibly get, or if they make any trade, they're better off. Okay. All right. Um, okay. Okay. Questions on this type of problem? So with these two examples, kind of the same idea but different scenarios, but you got to go through these with the process. And so part A is going to be just plot the initial curves. Part B, determine which country has a comparative advantage in what, and that's what they're going to specialize in. So you got to go through all the opportunity costs and determine the comparative advantage country and what they should specialize in. One's going to produce one, and the other's going to produce the other. Okay, then part C, for these questions, you're going to show column 1 before specialization and column 2 after specialization, and just by doing that, there should be some gain in the goods in aggregate. D, you got to list the limits of the terms of trade. All right, so state the state one country, start with the good they're going to specialize in and show the initial exchange rate, and the other country with the good they're going to specialize in and state their initial exchange rate, and then show how a trade is going to benefit both countries by being in terms of the same good. Okay, like this. Then part E, you're going to, so we got this, we got this, you're going to do the trade that's given. All right, it's going to tell you a trade. Okay, do the trade here in column 3. Then show the outputs after trade for both countries, for both goods, and then there should be some gain, at least in one of the goods, that you can show from going from column 1 to column 4. Okay, and then part F, what we just did is show the new curve, which essentially start with the point they're specializing in, and then show all the possible points they can get to by trading at that fixed exchange rate. In this case, it's 1 to 1.5, or other way would be 1 to 2/3. All right. Everyone have a good idea of what to do here? Any questions on this problem? All right. Okay. Okay. So under study guides, that the Excel file I showed you the examples for chapter 16. If you want to look at that, if you're going to do it in Excel, you can use that as a nice little template for your homework assignment. So let me show you the homework assignment, which is essentially another question just like this, similar to this one. Uh, Okay, so homework assignments, chapter 16 there. Okay, so here we go. This is well, without the answers, this is another one that kind of just like we went through two big examples. You can use those to kind of refer to the steps. But here's your homework for chapter 16. So you got um, a production possibilities table for Kentucky and Cuba, and they're they have different alternatives for cigars and bourbon, and these are the different conditions they can produce at before. All right, so you're going to go through and plot the initial curves. Okay, you're going to find who has a comparative advantage in what. All right, you can probably guess just by uh, you know the goods and the domestic locations what who's going to produce what, but um, you got to figure that out. And then what's the total gain in cigars and bourbon just from specializing? Find the limits, okay, in terms of one of the goods, and then we're going to trade. I made it nice and easy or nice and simple. We're going to trade uh, 1 million cigars for 1 million bottles of bourbon. So 1 to 1, and then we're going to trade 50 million cigars for 50 million bottles of bourbon. So 50 to 50. So nice 1 to 1 trade. Okay, then go put out the whole columns and find the total gain for both goods for both Kentucky and Cuba. And part F, just draw the new curve, which is going to start with the specialized part and show all the possible trades they can make to be better off uh, from the initial allocations of part A. Okay, so there's that one. That's going to be due next Monday. So let me know if you have any questions about this. All right, so you guys can exchange notes or try to work together. Or if you get stuck, you can send me an email and I can try to help you. But try to follow the same process we just did with those previous two, and you should be fine. But um, this will give you nice practice for the take home question. Okay, so um, All right. Make sure if you're going to do the chapter 9 homework, you put that in, you get that in there by today. So chapter 9 homework is due today. Chapter 16 homework is due next Monday. And looks like I'm a few weeks behind on grading, so I'll try to get your 7, 8, 9 homeworks, uh, the grades up to date by next weekend and post your grades for those. And it looks like what I have scheduled for next week is we'll do a little review and some practice problems for midterm 2. And then you'll have the midterm 2, which will be due a week, basically 2 weeks from today. And then we'll move on to the macroeconomic stuff after that. Okay. I think that's all we need to do for today. So uh, let me know if you have any questions on that homework assignment. That's your work for next week, and that's all we got for this meeting. So thank you for joining, and everyone have a good week. And I'll see you next Monday, and we'll do a little review session again for the second midterm. So thank you.
Thanks, Professor. Have a good week.
You too.
Thank you, Professor.
Thank you.